Hey, Math 135, what's up? In this video, we're going to be looking at some examples from 2.4 and 2.5 on matrices and matrix multiplication. Actually, we're going to be focused primarily on, or entirely on matrix multiplication in this video. If you're struggling with matrix addition or subtraction or scalar multiplication of matrices, that's not something that's covered by this video. We're going to be doing just matrix multiplication. For number one here, we're given three matrices, A, B, and C, and we want to look and determine if the products are possible, and if so, what they would be. So remember, for instance, in part A, when we're looking at A times B, just thinking about whether or not that product is even possible, we want to look at the dimensions of these two matrices. A, the dimension of matrix A, it's got 2 rows and 3 columns, so it's a 2 by 3 matrix. And B has 3 rows and 1 column, so it's a 3 by 1 matrix. And since these middle two numbers match, then we can do A times B. The dimension of A times B, if we do AB, the dimension of A times B is going to be a 2 by 1 matrix. So it's going to have 2 rows and 1 column. So it's just going to have these 2 entries here. All right, and the way that we're going to find those entries is we're going to take the first entry. We'll take the first row of A times the only column of B. So we're doing 1, 1, 5 times 2, 1, 0. Doing our row times column operation, that would be 1 times 2 plus 1 times 1 plus 5 times 0. And that gives us 3. So that's the entry, the very first entry in A times B. And then for the second entry, we're taking the second row of A times the only column of B. So taking the row vector 2, 1, negative 1 times the column vector 2, 1, 0. And first times first, 2 times 2. Second times second, 1 times 1. And third times third, negative 1 times 0. And that'll give us 5. Okay, so A times B is a doable multiplication, and the result is the 2 by 1 column matrix 3, 5. In part B, if we try to do B times A, well, B is a 3 by 1 matrix, and A is a 2 by 3 matrix. These two middle dimensions don't match, so we can't do B times A. B times A is not a meaningful operation for those two matrices. All right, if we want to look at part C, looking at A times C, again, start with their dimensions. A has 2 rows and 3 columns. Again, 2 rows, 1, 2, and 3 columns. So it's a 2 by 3 matrix, whereas C has 3 rows and 2 columns. So C is a 3 by 2 matrix. The middle numbers match, so we can do A times C. And when we do A times C, the result is going to be a 2 by 2 matrix. So maybe let's copy these matrices down here. 1, 1, 5, 2, 1, negative 1. And we're going to multiply that by C, 2, 1, 0, negative 1, 2, 4. And now the resulting matrix, when I do this matrix multiplication, like we said, is a 2 by 2 matrix. So we're going to have four values that we need to find. The first value in the 1, 1 slot would take the first row of A times the first column of C. So we would do 1 times 2, our first times our first, plus 1 times 1, plus 5 times 0. That gives us 3. 3 in the first slot. I can say I'm really lazy there. Don't be lazy. 3. All right. The second entry, or I guess this entry right here, in the first row and second column, the entry in the first row and second column of the product, I take the first row of A times the second column of C. So I'll do 1 times negative 1 plus 1 times 2 plus 5 times 4 and that should give you 21. I'm kind of going quickly through some of the calculator activities here. I did that ahead of time so that we don't get bogged down in the calculator work. But if you need to pause and do some calculator work, just to verify, pause the video. Okay, so our entry here in the first row, second column of the product will be 21. Let's go ahead and clean a little bit of this up. I think we're done with the first row of A, so maybe I don't need to clean that one up. But we're going to be reusing, reusing all the things from C. So we'll go ahead and clean those up. 2, 1, 0, negative 1, 2, 4. All right. So the next entry we want for A times C, we want the second row, first column. So I'll take the second row of A times the first column of C. So we'll do 2 times 2 plus 1 times 1 plus negative 1 times 0. That'll give you 5. And then for the very last entry here in the second row of our product matrix and second column of our product matrix, we'll take the second row of A times the second column of C. We'll do, let's see, 2 times negative 1, 2 times negative 1, 1 times 2, and then negative 1 times 4. And when you add all those up, you should get negative 4. So that's our last entry of AC. We can look here and see if we can do C times A. Let's see, C was a 3 by 2 matrix, 3 rows and 2 columns, and A is a 2 by 3 matrix. So our middle terms match. We can do this multiplication here, and the outside terms give us the dimension of that new matrix. So we can do that one. All right. We're doing, let's see, the matrix C, 2, 1, 0, negative 1, 2, 4. The matrix A, 1, 1, 5, 2, 1, negative 1. And like we said, we're going to end up with a 3 by 3 matrix here. So there's going to be nine entries to compute. So let's just roll up our sleeves and do it. For the entry in the first row, first column, we want to take the first row of C times the first column of A. That'll be 2 times 1 plus negative 1 times 2, which will give you 0. I really do need to come up with some hotkeys for this eraser. For the entry in the first row, second column, I want to take the first row of A times the second column of C. So 2 times 1 plus negative 1 times 1, which gives you 1. And for the entry in the first row, third column, we're taking first row of C times the first column of A. So 2 times 5 plus negative 1 times negative 1. There's my negative 1 from the first row of C, the negative 1 from the third column of A, and that comes together to give you 11. Right now, these, I think it's obvious, probably obvious in class, definitely obvious in the videos. These computations, matrix multiplication, is very tedious. None of the individual steps is really challenging once you get the hang of it. It's just a matter of maintaining some focus and getting the job done. So let's try to maintain our focus and get the job done here. We are focused now on the second row, first column of our product. So I'll take maybe I'll switch colors here just to keep myself focused. I'll take my second row of C times the first column of A. We got 1 times 1 plus 2 times 2, which is 5. For the second row, second column, I'll take my second row of C times my second column of A. That gives me 1 times 1 plus 2 times 1, which is 3. And then the last entry here in this row will be second row, third column. I'll take my second row of C times my third column of A. We got 1 times 5 plus 2 times negative 1, which also gives you 3. All right, so now we got those 3 entries. We can fill them in. 5, 3, 3. And then we just got one more row left for our product matrix. That's our third row. So we'll switch colors one more time here. Go with the puke green. We're taking our third row of C, first times the first column of A. So we got 0 times 1 plus 4 times 2, which will give you 8. And then for the next entry, take the last row of C times the second column of A. So 0 times 1 plus 4 times 1 gives you 4. And then the very last entry we need here in our third row, third column, take the third row of C times the third column of A. That'd be 0 times 5 plus 4 times -1 gives you -4. All right. So that was a bit of a doozy. But like I said, if you keep your head on straight, try to stay focused, they're not that bad. They're just tedious. But with practice, you can start to whip them out pretty quickly. And depending on how good you are with the mental math, you don't necessarily have to write down all the computations. Okay, in E, we're investigating A squared. That would be the same as A times A. Just like when you multiply numbers, A squared for matrices indicates that we want to do A times A. And just look at the dimensions of A. A, the first matrix, is 2 by 3. And the second A is also a 2 by 3 matrix. And our middle two dimensions don't match. And so we can't do A times A. In F, we're looking at AC squared. So that's taking the matrix AC times the matrix AC. This is the matrix that we found in part C. It's a 2 by 2 matrix. So the first AC is a 2 by 2. And the second AC is a 2 by 2. The middle dimensions match, and so we can do the multiplication. And the outer dimensions, everything here is 2's. The outer dimensions tell us that the product, the AC squared, will be a 2 by 2 matrix. And we can go ahead and dig into that. Let's see, we got the matrix AC is 3, 21, 5, -4. And we're going to multiply that by itself. 3, 5, 21, -4. And the result is going to be a 2 by 2 matrix. I'm just going to go ahead and leave the dots out so I don't have to keep erasing them. But our first entry would be in the first row, first column. In order to compute that, I'll take the first row of AC times the first column of AC. That'll give us 3 times 3 plus 21 times 5. And I got to tell myself here I did the wrong problem in my notes, so I'm going to have to do some calculator work here. 3 times 3 plus 21 times 5 gives 114. So that would go in row 1, column 1 of AC squared. In row 1, column 2, we want to take row 1 of the first matrix times column 2 of the second matrix. So 3 times 21 plus 21 times 4. And that'll give you 147. For our bottom row here, again, we're making a 2 by 2 matrix. For our bottom row, in the second row, first column, I'll take my second row times my first column. So 5 times 3 plus -4 times 5, which gives you -5. And then for the very last entry, in the second row, second column, I'll take the second column times the second row. So 5 times 21 plus -4 times -4. that'll give you 121. So we're picking up the pace a little bit here. Hopefully you're getting the hang of the row times column multiplications. It's really, really important that you just do enough examples. I know they're tedious. Just do enough examples to where this is routine, and you don't necessarily have to think too hard about your row times the column. All right, two last ones to think about, BC and CB. Let's see, B was a 3 by 1. B is a 3 by 1. 3 rows and 1 column. And C was a 3 by 2, 3 rows and 2 columns. And since our middle dimensions don't match, we can't do that multiplication. For CB, C was a 3 by 2 matrix, and B was a 3 by 1 matrix. And again, we see our middle dimensions don't match. The number of columns in C needs to match the number of rows for B. All right, so neither of those multiplications can be done, and I'm happy about that because matrix multiplication is boring. Okay, for number 2, Olivia and Isabella have stock holdings which are represented by the following matrix. So matrix A here, it's telling us that Olivia has 200 shares of FB. I guess that's Facebook. I think that's supposed to be Facebook. 300. Olivia has 300 shares of Home Depot, I think that is. 100 shares of whatever PG is, and 200 shares of, looks like Starbucks. Maybe PG is Procter & Gamble. I don't know. Anyways, Isabella has 100 shares of Facebook, 200 shares of Home Depot, 400 shares of, we'll say, Procter & Gamble, and no shares of Starbucks. Next, at the close of trading on a certain day, the prices of the stocks are given by this matrix. So Facebook had a share price of $27, Home Depot $24, Procter & Gamble $63, and Starbucks $56. In part A, they just want us to find the matrix AB. So A is a 2 by 4 matrix, 2 rows and 4 columns. B is a 4 by 1 matrix, 4 rows and 1 column. It's a column matrix. And our middle entries match, so we can do this multiplication. The outer dimensions tell us that A times B is going to be a 2 by 1 matrix. So I take matrix A, 200, 300, 100, 200, 100, 200, 400, 0. When I take that matrix times the B matrix, 27, 24, 63, 56, that'll give us a 2 by 1 matrix. So there's going to be 2 entries that we need to find. The first entry, we'll take our first row times the only column. So 200 times 27 plus 300 times 24 plus 100 times 63 plus 200 times 56. And that's our row times column operation. And that should give you, when you work it all out in the calculator, 30,100. So maybe I didn't quite draw this matrix big enough to contain the numbers. Now let's just pop in the number first and then draw the other one. 30,100. And then the second entry, again, this is a 2 by 1 matrix. The second entry we'll find by taking our second row times the only column available. So 100 times 27 plus 200 times 24 plus 400 times 63 plus 0 times 56. And that works out to be $32,700. Okay, so the numbers are a little bit bigger here, but the idea is no different. And if you take your, you don't want to take all day and all night to do it, but if you just do it without worrying about the big numbers, then it shouldn't be that big of an issue. All right, part B, explain the meaning of this matrix. And I guess one of the questions that you might reasonably have is, all right, Dan, all these computations are things that computers can do. Why do we have to learn how to do it? And I think the idea for why we're working on these row times column things is so that we can understand what these numbers represent. 200 times 27, well, we're looking at Olivia's shares. She had 200 shares of Facebook valued at $27 a piece. So 200 times 27, that's how much Olivia's Facebook shares are worth. 300 times 24, well, that's Olivia has 300 shares of Home Depot. They're worth $24 a piece. So 300 times 24 is what Olivia's Home Depot shares are worth. So each of these multiplications here represents how much Olivia has, what her stock holdings are in dollar amounts for each of these companies, and the total amount is her total, what her shares are worth. So understanding what the computation is helps us understand what the result of the computation is. All right, so we could say that this matrix represents the holdings, the total holdings in dollars for Olivia and Isabella. Okay, Olivia, that was our first person, right? Yes, Olivia has $30,100 worth of stock, and Isabella has $32,700 in stock. So when you need to interpret the results of a matrix multiplication problem in the context of a story, think about what this computation represents. All right, I think that'll do it for this video. If you have any questions about matrix multiplication or the interpretation stuff in the story problems, please don't hesitate to send me a message on IvyLearn or an Ask Your Teacher in WebAssign. And that'll be all.